Virtual worlds are about to get a whole new kind of intelligence, one that doesn't just follow scripts but truly understands how things move and interact. Microsoft's Muse AI is learning digital environments, generating entire sequences, and even helping bring old classics back to life. Okay, so Muse is described as a world and human action model, shortened to WHAM, because it doesn't just generate game visuals, it also generates actions, or both at the same time. It's basically an AI system that's been trained to understand three-dimensional game environments and game physics. That means it can look at a game, recognize how things work in that world, and generate new gameplay that fits right in with what a real person might do. This is not just some theoretical idea either. Muse has been shown off in action, generating visuals of a game at about 300 by 180 pixels resolution. Admittedly, that's pretty small compared to the 1080p or 4K we all love in modern gaming, but hey, it's a huge step up from the 128 by 128 resolution Microsoft's earlier prototypes produced. Now, how did we get here? The inspiration reportedly dates back to late 2022, right after ChatGPT blew everyone's mind with text-based generative AI. Katja Hoffman, a senior principal research manager at Microsoft Research in Cambridge, UK, started wondering how these same transformer-based models, like the ones behind ChatGPT, might work for video games. Her team, called Microsoft Research Game Intelligence, had already gathered a ton of gameplay data, with player consent, from the Ninja Theory title Bleeding Edge. If you're not familiar, Bleeding Edge is a 4 versus 4 Xbox game that came out in 2020. All of its matches are played online, and with consent from the players, Microsoft captured the visual data and the controller actions from these matches. Get this, they ended up accumulating over 1 billion images and controller actions, which is equivalent to more than 7 years of human gameplay. That's a massive data set. So naturally, Hoffman and team thought, what if we feed all of that into a transformer-based model? Could we basically teach an AI to understand and then generate brand new gameplay sequences? Turns out, yeah, they could, and that's exactly what Muse is. They trained the model using powerful compute clusters that included V100 GPUs at first, and then upgraded to H100s. The scaling process wasn't easy, but eventually the team got their pipeline stable and was able to handle large training runs. Once they had a working prototype, they tweaked it for higher resolution image encoders, like going from 128 by 128 pixels to 300 by 180 pixels. Tested it on different in-game maps, and found that Muse could do all sorts of interesting stuff. It can, for example, be prompted with real gameplay footage for a few seconds, plus the controller inputs, and then it continues generating the next several minutes of gameplay, often matching what the actual real gameplay looked like. Or it can just take the button inputs and imagine how the game would respond. The better it matches real game physics, the more it shows it understands how Bleeding Edge works. What's really exciting is that, along the way, the team discovered 3 big capabilities that are key for creative game development: consistency, diversity, and persistency. Consistency is about how accurately the generated gameplay follows the rules of the game world. Like, does your character walk through walls, or do they obey typical physics? Does the AI interpret button presses like a normal player would? Diversity is about making sure the model can produce all kinds of different scenarios, so we don't end up with a single repeating pattern. And persistency means if you modify the game world mid-sequence, like, say, copy and paste a new character into the screen, the AI can keep that new character around realistically in subsequent frames. Those points are super relevant for real game developers. No dev wants an AI that can only do one thing or produces the same environment every time. They also don't want an AI that breaks a game's internal logic. So, in that sense, Muse looks like a big step forward for generative AI in game development. Interestingly, teams at Microsoft not only tested the model's capabilities in their labs, but also built a so-called WHAM demonstrator, a special prototype tool that developers and creators can use to try out Muse themselves. With it, you can load initial frames of Bleeding Edge gameplay or even a single promotional image of the game, then watch Muse produce various sequences to follow up that intro. Microsoft has also released a lot of these findings publicly. The model weights are being open sourced, along with some sample data plus an executable for the WHAM demonstrator. Researchers or curious developers can experiment on Azure AI Foundry to see for themselves what Muse can do. There's a detailed paper in the journal Nature, which is considered a significant milestone, especially for bridging the gap between generative AI for text and generative AI for video gameplay. According to the team, it shows how we can leverage large amounts of gameplay data to teach an AI not just to manipulate images, but also truly reflect on how a virtual environment should evolve over time. Now, of course, this is all early research. Nobody's saying you'll be playing a fully AI-generated AAA title next month, but the potential is pretty wild. It might be used by game creators in the future to prototype levels quickly, explore new ideas, or even figure out how to preserve or modernize classic games. And that's another thing. Microsoft Gaming CEO Phil Spencer and others at Microsoft say they're exploring ways that Muse might help revive old games that are no longer playable because their original hardware is obsolete. A model could theoretically learn the entire game from recorded gameplay data and then re-render it for a new platform without the original engine. That's obviously a long-term vision, but it's the kind of possibility that's got a lot of people excited. During a press briefing, we also heard that some teams at Xbox are thinking about how Muse and generative AI more broadly might be used for brand new experiences or updates to existing games. Some short, interactive AI-powered demos might show up in Copilot labs soon, giving folks a chance to get hands-on with these concepts. Fatima Kardar, a corporate vice president of gaming AI at Microsoft, emphasized that each studio at Xbox has the freedom to decide how or if they want to use generative AI. She says it'll all be based on the specific game director's creative vision and the team's goals, rather than forcibly imposing AI on every project. Not everyone in game development is thrilled, though, because it's a pretty volatile time in the industry. One article mentioned that in 2024 alone, 1 in 10 game devs lost their jobs due to layoffs. There's concern that generative AI could replace human artists and level designers, for example. But according to Ninja Theory studio head Dom Matthews, the goal isn't to generate entire games automatically. The interest is more in how to make the development process easier and more efficient, so devs can focus on the things that really require a human's touch. In other words, it's a tool that can free up time rather than a tool that eliminates the need for actual people. We also got to see some glimpses of the future from Katja Hoffman. She showed a real-time version of Muse that generated frames on the fly at a modest 10 frames per second. She even dropped objects into the environment, and the model reacted logically, rearranging the environment accordingly. That demonstration, while still low-res, gave a taste of how these AI-driven worlds might one day become truly interactive. Imagine open-world games or creative sandboxes that can expand themselves in real time based on what players are doing, or that can adapt to your input in fresh and unexpected ways. For us players, the near future might mean new ways to toy with game prototypes. Maybe we'll be co-creating levels with generative AI, or letting the AI swiftly adapt an existing level to a new challenge. All these possibilities are super intriguing. And if they figure out how to apply that old game preservation idea, we could see a wave of retro titles brought back. That might be perfect for anyone who never got to experience certain classics the first time around. Ultimately, Microsoft emphasizes that the real reason behind sharing all of this data, the open source weights and the documentation, is to encourage more researchers and developers to explore what's possible and build on top of it. Because while ChatGPT and GPT-4 have shown how AI can do wonders with text, gaming is an even more complex domain. It's not just about words, it's about physics, three-dimensional spatial logic, real-time decision-making, and so on. If Muse can handle these challenges, the scope for generative AI in interactive entertainment and beyond could be enormous. So let me know in the comments what you think about Muse, generative AI in gaming, or game preservation. Are you excited, worried, or a bit of both? Personally, I can't wait to see what new kinds of creative magic developers come up with now that they have these tools in their hands. All right, thanks so much for hanging out, and I'll catch you in the next one.